A Boolean is a built-in data type in Python that can be either true or false. For example, I can write that the variable I know Python is equal to true. I know that it should be false, but let's not focus on that. Now, do you see how true is capitalized? This is very important, otherwise Python doesn't know that you are referring to a Boolean value. This is because true and false are keywords in Python, meaning that they are solely reserved for Python. For example, if I try to create a variable false with capital letter and assign the numbers 1, 2, 3, Python doesn't like it and will throw a syntax error. However, if I instead write false in lowercase, Python will accept the assignment. Fortunately, some of my favorite words, like slay and queen, are not keywords in Python yet. If you are wondering whether Python has taken one of your favorite words for itself, you can do the following. Start by importing the keyword module. You can think of modules as small packages in which you load features into your workspace. Then you call the print function followed by the keyword module dot and keywlist, which stands for keyword list. In the result, along false and true, there are other keywords such as and or, which we'll touch upon shortly. Also, here I use the print function to print out text or variables, which in this case are the reserved keywords. You can see that I set the parentheses, and that's because in Python, a function is always followed by parentheses. What you put inside the parentheses are the parameters or inputs of the function. The last thing I want to mention is that the dot between the keyword and the keyword list. Dot is used to access properties of an object in Python. Pretty much everything in Python is an object, which means that if you type dot after any variable, followed by tab, you'll be able to see the properties or functions of that object. This will be useful as we go on, because we'll cover just a few of them in this lesson. In the end, the idea that I want you to have is that Booleans are your trustworthy data type that can be either true or false, and never anything else. Now, let's spice up things a little bit by introducing the logical operators and, or, and not, upon which Boolean algebra is set. These operators allow us to create a richer logic around the Boolean values we've just learned, depending how you set them together. Feel free to skip this section if you are already familiar with the concept. For now, I want you to be comfortable with some of these rules. Let's first see how Booleans work with the AND operator. To start off, when you have true and true conditions, the result is always true. When you have true and false, then the result is false. Lastly, false and false is also false. For use cases with the OR operator, true or true results in true, true or false is still true, and lastly, false or false equals false. Can you see a pattern here? Essentially, this means that you only need a single false condition within several ANDs for the result to be false. And in contrast, you only need a single true condition within several ORs for the result to be true. Okay, you may be wondering, I've just learned these Boolean types, why is it so important to also know these rules? Well, besides that you'll finally look cool to your friends, you can also use this in different scenarios. For example, let's create two statements, is raining equals true and as umbrella equals false. Now I want to create a variable, leave home, which relies on our two statements. Leave home will be true if it's not raining, or if it's raining and I have an umbrella. How do we translate this sentence into a proper Boolean condition? To start off, we have two main conditions which allow us to leave home. Option 1 is when it's not raining. Option 2 is when it's raining but we have an umbrella. We only need one of them to be true to leave home, meaning one or the other needs to be true. It's probably a good time to apologize to my fellow British listeners, as this example will probably make no sense to you. In option 1, we negate the is raining condition by adding the not operator beforehand. I've not mentioned this operator in the rules, but essentially it negates whatever the result we previously had. We then need to write the OR condition to show that we can leave home by allowing one or the other. But how exactly do we write the second condition? Well, for this I will write within parentheses both the conditions is raining and has umbrella, to show that both need to be true if I want to leave home. Why do I need the parentheses? Well, just like in maths, they signal that I'm prioritizing each option before evaluating if any of them is true. With parentheses, the code will become more readable and I make sure that each condition is individually evaluated first, and only then the result of the different options is computed. Before I print the result, can you try to guess the outcome? If you said false, then you are correct. Why is it false though? because it is raining, and therefore option 1 is false, as we are negating the true condition. Also, because it is raining and we do not have an umbrella, the second option will read true and false, which we can see from our table that this is false. We now know that both conditions are false, and as we've seen before, false or false equals false. Last thing I want to touch on is the priority of logical operators, from highest priority to lower, meaning what Python will try to compute first when looking at all these different operations. First off, Python will evaluate whatever is inside parentheses first. Afterwards, the not operator takes priority, following by the and operator, and lastly, we have the or operator, which has the least priority. This means that if you remove the parentheses in our example, you will get the same result, but you lose the readability of what it is that you're trying to accomplish. When I say you lose the readability without the parentheses, I mean that when you show this example to your friends in a couple months from now, you won't be able to explain it. Alright, that's it. To summarize, we've learned about the Boolean type with the respective values true and false. We've also learned about the reserved keywords and how to print values. And lastly, we've seen how we can build more complex logic using the operators and, or, and not, while mentioning their priority when computing the results.